Hi, and welcome to CubeTube, the channel where we discuss every element in the periodic system and also do experiments with it. If you don't want to miss an episode, make sure to subscribe. Question of today is simple. What happened in the intro? We saw a light bulb, it started to glow, but there was no immediate source of electricity, it seemed. Now today is an experimenting video again, and the device that we will also be using for the next two episodes. The specific device we see here is the Tesla Coil, and it was invented by Nikola Tesla, a great inventor. And if you think I should do an episode on him, let me know in the comments. Now, what is a Tesla Coil? A Tesla Coil is simply stated a device that is used to produce high voltage, low current, high frequency alternating current electricity. Now, that probably still doesn't say much, so let me rephrase that sentence. A Tesla coil is a device that produces very high voltage electricity that creates fast and powerful electrical sparks and can even send electricity through the air. Now that sounds magical, right? So let's dig into how that works. The Tesla coil works by first increasing the voltage using a transformer and storing the energy in a capacitor. Now the capacitor which keeps the electrical energy between two metal plates separated by an insulating material, and then quickly releases this energy through a spark gap, creating back and forth current in the primary coil. Now this coil is part of the Tesla coils and is mainly copper wire being tightly rolled up. Now this current creates a rapidly changing magnetic field around the primary coil. This changing magnetic field induces a high voltage in the secondary coil, which is then set to resonate at the same frequency. The high voltage from the secondary coil builds up to, at the top load, creating visible electrical sparks, and then send the electricity to the air. Now that sounds awesome, right? Now let me show you some stuff. So first of all, what we see here is an ion windmill. And since I'm Dutch, I really love windmills, so this is my favorite experiment of today. So how does the ion windmill work? Well, basically it creates sparks, as you can see, and those sparks heat up the air. And because the air is heated there, basically it gives a little bit of a push to that windmill, and it starts to rotate. Now I also have here two lamps that contain a noble gas. Why that is I will explain in a second, but you can see as soon as I held them closer to the Tesla coil, the light bulbs will start to glow. Now here you can also see I'm doing the same thing with a savings lamp and a TL light. Now that is interesting, right? We just hold them close and all of a sudden they will start to glow. So, what does this have to do with chemistry? Well, some chemical elements have properties in such a way that you can use the electricity to make lights burn. Now, to which elements does this apply? Well, this would apply to noble gases. They are the elements from group 18, and they're special because their electron configuration is perfectly full. Now, in earlier episodes I explained that the electron shell have a limited amount of electrons they can store, while other elements are reactive because they want to strive for that perfect configuration. Noble gases are really fine with how they are. They're pretty self-confident and do not react with other chemical elements that well. In fact, they're called inert gases, which also make them extremely hard to detect. So why am I telling this, and why am I using physics on a chemistry channel? Well, a noble gas may be very inert when it comes down to other elements. There are ways to detect noble gases, and this is what we are seeing and doing here. The small lamp that I used, like almost the LED lights, are small neon lights, and they have really small amounts of neon in there, and that's a noble gas. And as you can see, it turns nicely orange in this case, and here is why. A noble gas will burn next to a Tesla coil because of the high voltage from the Tesla coil ionizes the gas. When the Tesla coil generates high frequency, high voltage electricity, it creates a strong electric fields. Now these electric fields have enough energy to strip the electrons from the noble gas, turning them into positively charged ions and free the electrons. Now this process is called ionization. Once ionized, the gas can conduct electricity, and the electricity from the Tesla coil excites the gas atoms. When these excited atoms turn to the normal state, they release energy in the form of light. And that is what you're seeing here. And this is why noble gases like neon, argon, and others that we will discuss will glow with different colors when they are exposed to the electric field of a Tesla coil, creating the appearance of burning lights. And there is the answer to the question of today. What happened in the intro when the light started burning without a visible electricity source? The answer was there is an invisible electricity source that excites the electrons and makes the lights burn. So that was the episode. I hope you were as excited as the ions that we were showing earlier. Next week's episode, we will do a follow-up on this episode, so make sure to subscribe if you don't want to miss that one. See you next week.